Okay, so today we're going to learn about postulates. So this is lesson section 4. And in this lesson, we're going to see some postulates, and then we're going to actually also get some diagrams or some pictures, and you're going to have to answer some questions based on the given postulate. Now, when you are memorizing these postulates, you don't need to memorize that postulate number 5 states that through any 2 points, there is exactly one line. Just know that there is a postulate that exists that states that through any 2 points, there's exactly one line. Now, we already learned this. This is what we learned in chapter 1. When we name a line, we name it with 2 capital letters. Now, the key word here is the word exactly. So exactly one line. So for example, if I were to draw a line here, or put 2 points, and then draw a line through it, there's only one line that is going to go through both of those. Remember, a line continues in both directions forever. So even if I were to draw another line, it's still the same line going through those same points. So there is exactly one line that goes through any 2 points. So on the quiz next Monday, I'm going to ask you to state this postulate. The question won't say, tell me what postulate number 5 is. What I'm going to do is I'm going to give you perhaps the first part of it, and I'm going to say, through any 2 points, there is blank. And you would fill in exactly one line. So you're going to have to memorize the postulates that are in this lesson and be able to complete the sentence with whatever words need to be filled in. Again, I'm not going to say, tell me what postulate number 5 is. I'm going to give you part of it. Because in a different textbook, it could be postulate number 5 could be something different. The way that they've numbered these are the way that they occur in our textbook. Every textbook would name them differently. Okay, so that is postulate 5. Postulate 6 states that a line contains, now here the key word is at least 2 points. There could be more points on the line, but all we need is a minimum of 2 to make a line. So for example, if I have A and B here, I can make my line, but also on that line could be point C. So we just need at least 2 points to make a line. And that's postulate 6. Postulate 7 states that if 2 lines intersect, then their intersection is exactly 1 point. So what that means is if I have 2 lines and they intersect, their intersection occurs at exactly 1 point. So that would be a picture that would represent postulate 7. For postulate 8, this states that through any 3 non-collinear points, there is exactly one plane. So if I were to draw 3 points that are non-collinear, not on the same line, they are in a plane. So it could be points A, B, and C. Exactly one plane. Remember, the edges of that plane go on forever. So if I were to draw a bigger rectangle, it's still the same plane because these edges are getting bigger and bigger and wider, and they keep going. So it's always one plane. It's kind of hard to represent it, which is 2D. Everybody good on this slide? Okay. Again, you're going to memorize these postulates. We will be using these postulates for our proofs coming up. Remember, a postulate is based on a definition or a rule. It's something that's already a fact. The next slide has some more postulates. We're going to talk about those momentarily. Good? Okay. Next, through exactly 1 point, postulate number 7. So you wouldn't tell me postulate 7, you would actually give me all of these words of what postulate 7 states. So if two lines intersect, then 11 that you need to memorize for the quiz next week. Okay, and throughout the course. When we get to the proofs, you're going to be restating some of these postulates. We'll see postulate number 9. Postulate number 9 states that a plane contains at least 3 non-collinear points. And what this means is we can have more than 3 in our plane, but we need a minimum of 3 to name the plane. So again, if I were to draw a parallelogram looking shape, I could have my 3 points in here, but I could also have a 4th one or a 5th one. It doesn't matter. So you need at least 3, but you could have more. That's what postulate 9 states. Postulate 10, it says if 2 points are in a plane, then the line that contains them is in that plane. So if I were to draw a plane and I place 2 points in there, A and B, I could see that the line that those 2 points are on is also in the plane. Yes?
Postulate 9, why can a plane contain 2 points?
Because by definition, the plane is defined by 3 non-collinear points. So you need 3 points to name a plane. So that's why you need at least 3. Postulate 11 states that if 2 planes intersect, then their intersection is a line. Now, again, it's hard to draw. I can describe with the classroom. I could talk about the ceiling and where it meets this front wall. So the roof or the ceiling comes over here, and then the wall comes up here, and their point of intersection is a line. Or if I take my tissue box over here, and I can think of this as a plane, and think of each one of these sides of the box as going forever. So this would be a plane here, and then the top could be a plane, and where these two come together is a line, because these would continue forever. So when 2 planes intersect, their intersection is a line. This was on the last test. So remember, 2 planes always intersect at a line. So let's see. Could draw a plane, and then maybe a vertical one. And I don't know, their intersection could be a line. So know where they cross, they make a line. Everybody good on this slide? Anybody still need it? Yes? Okay. Anybody still need it? Still need it, Daniel? Are you good? Good? Okay. Our intersection is at exactly that a plane contains at least 3 non-collinear points. Postulate 10 states, if 2 points are in a plane, then the line that contains them is in that plane. True. All right. Next, we're going to talk about theorems. Now, before the postulates, those were based on definition and rules. However, a theorem is a statement that has to be proven. Now, luckily for you guys, people have already proved these theorems for us. So, the work's already been done. We just have to understand how they went about proving these theorems. So a theorem is just a statement that has to be proven. Let's look. One state. So let's look at the picture. So let's 5. So here's our first diagram. And here's a statement about it. And we're going to read it and we're going to see why it's true. We're going to look for little clues in our diagram. Now, when you have perpendicular lines, when they intersect, they form 90-degree angles. So that little clue that it's a 90-degree angle is important to us. So everybody see the little red lines here? This is indicating that these are 90-degree angles, which are formed by those perpendicular lines. So it says a line is perpendicular to a plane if and only if, and notice if and only if, here's my little biconditional. If and only if the line intersects the plane in a point and is perpendicular to every line in the plane that intersects at that point. So we can see the line going through the plane. So for example, yes.
This is just an example, right?
Yes, this is just an example. You're not memorizing this. Okay, so for example, if I have my paper and here's my plane, and let's say I were to put my pen through it, it would be perpendicular to the plane, and then any line that I would draw on here would also be perpendicular to that. And we would look for the right angles, those 90 degrees, to indicate that it is perpendicular. So this is just an example of how you can look for things in your diagram. I'm not sure what point, and that's what you postulate. No, and 2 point. Okay, next. So let's go ahead and look at this. Can anyone state, you don't have to tell me the number, but state the postulate that's illustrated in picture A. Valentina.
If two lines intersect, then they intersect at exactly 1 point.
Beautiful. Okay, so you would restate postulate number, say, for picture A. Picture B. Isabella.
If two planes intersect, then their intersection is a line.
Correct. And you would restate that postulate. Okay, so if two planes intersect, so if then they intersect at a line. Now, when you take this quiz, I'm not gonna, like if you drop a non-important word like an a or an at or a the, it's not gonna be wrong as long as you have the general idea of what I'm doing here, of what you're trying to describe. Pretty good on this one? And can someone tell me that are on? So we have, all right, next one. Now, in the homework, because the homework comes from this textbook, they're going to say, use postulate 9, use postulate 5, and they'll refer to the postulates as a number. However, when I give you a test or a quiz, I'm going to list what postulate 9 says. So let's go back to the notes and let's figure out what postulate 9 states. 3 non-collinear points in this diagram.
Point P contains point B, point A, and point C.
Good. So in plane P, or on plane P, it contains points A, B, and C. A and B are on the same line, but C is not. So that would be an example of postulate number 9. Postulate number 10, let's go back and read that line. Right there. Can someone tell me 2 points that are on a line, that are in the plane? Isabella.
A and M.
M is just the line. It's not a point.
Oh, B and A and M.
Good. So points B and A are on line BA. So just some kind of phrase or some example. So we're going to pull points B and A because they're on the same line. So again, on the test or the quiz, I would tell you what postulate 9 is, and then you would have to tell me from the diagram what letters or what figures or what points match to it. Pretty good on this one? Okay, let's look at that are in the plane. Oops. Example 3. Now, it's asking us which of the following statements cannot be assumed from the diagram. Now, we're not assuming anything. It has to have markings that are going to match with the postulate. So, are A, B, and F collinear? They are on the same line, so yes, we can assume that they are collinear. They're sitting right here on this line. Okay, next. E, B, and D, are they collinear? No. There's not a line drawn through them. It looks like it, but again, we're not going to assume anything. So we're going to say no here. What about, and if you haven't seen this symbol before, the upside down T, that represents perpendicular. So is line AB perpendicular to plane S? Can we tell that? Yes, we can. Because of the right angle mark here. If it didn't have the right angle mark, we wouldn't be able to say for sure that that was perpendicular. But because there's a right angle mark there, we do know it's perpendicular. What about CD and being perpendicular to plane T? Do we know that for sure, Valentina? We cannot assume that. There's no right angle there. So here's where it's touching. This CD is here, but there was no right angle mark. So we can't assume they're perpendicular. All right, now, this last one, the line marking should have been on top of the BC, not right here. So does line AF intersect line BC at point B? Yes. So we can assume that. Okay, everybody understand how we're going to look at the pictures and then they'll ask you questions. And again, be able to understand the vocab. All right, last one. Yes?
No, I'm gonna answer.
Oh, you're okay. All right, so can you name me a pair of supplementary angles? First of all, what are supplementary angles?
More than 180 degrees. Oh, 80 degrees. 180 degrees.
They equal exactly 180 degrees together. So give me an example. Name it with 3 letters.
TWB.
Okay, so she's saying T, W, together. I need 2 separate ones. Because TWV itself is a straight angle, but I need 2 angles to make it supplementary. It's a pair.
Oh, T and W and WB.
So say that again.
T and W and WB.
T and W and WV. We need 3 letters to name an angle. So what if I do this one and then this same one here, but name them separately with 3 letters?
PWT and PWV.
So PWT and PWV, you said? Good. That's one pair. Anybody see another pair? There's a bunch on here. David?
TWQ and QWV.
TWQ. And what was the second one?
QWV.
Good. QWV. And we're going to put the little angle thing, the slanted L looking in front. Okay? So the one he just gave us, let me do it in a different color. He said TWQ matching with QWV. All right? Anybody see another one? Kelly?
QWV and VWP.
So she's saying QWV right here, and then VW, did my P not come out? Here. Okay, that's another one. Good. Yes, you have another one?
I think so.
Okay.
I can't talk with you. QWT and TWP.
And TWP. So QWT here. Oh, it's not working. And then TWP. Good. We didn't say that one. Good. All right. Now let's switch to vertical. You guys got the hang of the supplementary. All right. I'm gonna erase here on my picture so I can highlight again. Anybody remember what vertical angles are? Everybody remember that? Tell me some up here.
A pair of this pair.
Yeah, just give.
PWV and TWP.
Good. Okay. PWV is right here, and TWQ is here. There's one other pair. It's going to be over here. This one with this one. Somebody give me those letters for the red. Yes.
PWT and VWQ.
Good. Let's see, where did this one? All right, everybody good on vertical? Okay, and again, put the little angle symbols in front. So those would be your pairs. Good. And that is the lesson. So memorize the postulates from